It's a pleasure to introduce my colleague here at the Surgical Artificial Intelligence Lab in Boston, and also part of the Critical View of Safety Challenge Task Force, Dr. Yutong Ban, who is going to talk about the purpose and the impact of a surgical data challenge.
Thank you for your introduction. Can you see my screen? Okay, so I'm Yutong Ban, and I'm from the Surgical Artificial Intelligence and Innovation Lab from MGH and CSAIL MIT. Today, I will talk about the technical aspect of a data challenge. So first question, what is a data challenge? Yesterday, I asked ChatGPT about this question, and it wrote me 3 paragraphs immediately. Frankly speaking, it is better than what I do. So let's see what it says. So first, a data challenge is a competition or a project that involves analyzing, interpreting, and presenting insights of a given data set, which completely makes sense. And also it says that participants in a data challenge may be asked to use statistical or machine learning techniques to identify the patterns in the data. The goal of the data challenge is often to generate new insights, develop innovation solutions to real-world problems, or advance the state of the art in a particular field. I think this description is very accurate, but maybe only the verbal description is not enough. Let's take an example. So imagine that we are taking an image classification challenge. We need to have a bunch of images as data. The task can be a classification. We would like to classify the images into dogs or cat. This is actually the simplest case we can have. In reality, it can be more complicated. So the data is not necessarily only be images. It can be images or videos, or even sound or the text, any forms of the data we can have. And the target task can be various as well. It can be classification to classify in the images. It is a dog or cat, or it can be object detection. Where is a cat? It can be sound recognition, for example, what is a person currently saying? Or it can be language translation. What is this sentence in another language? It can be different tasks. So given the data and the target task, our goal is to provide a platform to try the different solutions from the data to the target task. In the computer vision community, there are a lot of different data challenges. For example, the most famous one is ImageNet, which is an image classification data challenge, which we would like to classify the images into 1,000 different classes. And in the autonomous driving community, we have New Things Prediction Challenge, which is to predict the future trajectory of the driving cars. Also, you have the Coco Detection Challenge, which is the goal is to detect the bounding box position of the object in the image, and also the segmentation mask of the objects in the image. In medical imaging field, there are also quite a number of data challenges, like the BRATS challenge, which is for the brain tumor segmentation. In the surgical community, our colleague from the IHU Strasbourg have initiated the Instrument Action Tissue Triplet Challenge, which the goal is to recognize the interaction between the instrument and the patient's tissue. Moreover, we have an amazing grant challenge website. It is a medical image challenge website with over 300 challenges, and more than 1,000 algorithms has benchmarked their results on it. So given all of those data challenges, why is a data challenge important? So we have the data, and we have a task. We have a target task. The data its own has a data distribution and the task has its own distribution as well. So given the data distribution and task distribution, we would like to explore the solution space between the data distribution and the target task distribution. And now it's a deep learning era exploring the solution space, which means exploring the different network architecture designs for the different problems. The different network architecture designs can be convolutional neural networks, fully connected neural networks, or temporal neural networks like LSTM or transformers, all of those. As there are so many other ones, or it's a combination of all of those. So as we briefly mentioned, the data challenge provides us a platform to explore the solution space. We can use it to explore the different network architecture designs. Also, our goal is to find the optimal solution for the target problem. This optimal solution finding process is not immediate, which means it's not like you provide the data challenge there, as computer scientist will immediately find this optimal solution in a week or something. It requires several iterations and time to explore the problem. Let's take back to ImageNet classification data challenge as example. The data challenge was created before the 2010, and only until years of the iterations and people trying it for several iterations, and until 2016 or 17, in the application-wise, we got satisfying result. So that's about the data challenge. And what do we need for to create a data challenge? There are several key components of a data challenge, which I would say are data, annotations, data splits, and the evaluation matrix. First, about the data. There are two things we need to specifically care about in the data. It's about the data distribution and the data samples. For the data distribution, it needs to be close to the real-world data distribution, because finally, we would like to solve a real-world problem. So we would like the data to be representative to the real-world problem. And also, we would like to have the data samples to be diverse enough. For the dog and the cat classification problem, we would like to have the model, machine learning models, to see the different kinds of the dogs and cats, then provide a robust estimation classification of the task. Another key component is about the annotations. For the annotations, it can be different forms. It can be one label for the image, or it can be a bounding box on the image. It can be a polygon segmentation, or it can be only one text annotation description of the image. It can be different, any kinds of the annotations, but the annotations should be clean, accurate, and consistent. Because if the annotations are clean, accurate, and consistent, when we train a machine learning model, it can learn some consistent behavior. Another important key component is the data split. When we have the data, we need to split them into two sets at least. We need to split them into training set and test set. The training set is to use to train the machine learning model, and the test is used to evaluate the model. We encourage the similar distribution between the training set and the test set, so that the test set is representing the real problem, and it is a valid evaluation of the problem. And also, we need to make sure that there is no data leakage, which means the samples in the test set shouldn't appear in the training set. This is make sure that the evaluation of the model is valid. The last component is about evaluation matrix. When we evaluate the performance of model, it is good or bad, we shouldn't rely on a single metric, because we would like to evaluate the different aspects of the performance of the model. So we shouldn't have the single metric. We should cover the average statistics and also cover the different aspects. That's all about the data challenge. Let's go back to our SAGE's critical view of safety challenge. So let's go back to what ChatGPT would say. The goal of a data challenge is often to generate new insights, develop innovative solutions to real-world problems, or advance the state of the art in a particular field. In our case, we would like to develop innovative solutions to the critical view of safety assessment problems. And we would like to collect joint effort to make the deployment of the AI assessment of the critical view of safety possible. And it is the first data challenge organized by a surgical society effort influenced by computer scientists, surgeons, and industry, all of you here. And we would like to provide a platform for machine learning scientists to explore and address the critical view of safety assessment problem. And we would like to, and meanwhile, create a worldwide initiative to generate a holistic data set of the CVS. And meanwhile, our ultimate goal is to develop a generalizable and universally deployable AI to control the safety in cholecystectomy by artificial intelligence. This requires the joint effort by everyone here in this meeting. Thank you. That's all about my talk.